Hello everyone, in today's video we're going to be taking a look at nested for loops in Python. Now, for anybody who's ever heard of a nested loop before, your brain is immediately going, oh no, it's an AP test question all over again. Yeah, unfortunately. The cool thing with nested for loops is they allow you to loop a loop, which is actually tremendously useful to us, believe it or not. Now, generally from a programmer's perspective, I usually warn people when you start looping loops that loop loops, just be mindful because you're running up the iterator count, and that's also going to be slowing your code down or make it really, really messy. So let's go ahead and take a look at this problem. So what I'm going to do is I'm going to create myself a really, really goofy loop. And just kind of keep it really simple. I'll do 4x in range. I want it to go around 10 times. And what I would like to do is I like to print beep. Now, if I go ahead and run this code real quickly, you'll see that I get myself 10 beeps. Now, what I also wanted to do is I wanted to make 2 boops after each beep. How would I do this? I could just theoretically go in here and go like this. I could do boop, boop, like that. Now, if I run the code like this, it gets me something that looks like that. But, I feel like I need to make this more complicated. What if I needed to do 30 beeps after each? Okay, now it starts to get messy. Well, the good news is we can actually come in here and add another loop. So I'm going to go ahead and add in another loop that, what do we say, 30 of those? And we'll keep it simple for today. Print, boop. There we go. Now, the cool thing here, and you have to be very mindful, is that our iterator X and our iterator Y are different iterators. Now, the reason we have to do this is because if we don't do this and we come in here and make X in range, our loop is going to self-destruct because you're going to constantly be overwriting the value of X. And it'll work, but it's going to be a messy nightmare. So you have to be very, very cautious with that when you're doing it. Now, if I were to run this code real quickly, what you'll observe here is that we have beep, boop, boop, beep, boop, boop, beep, boop, boop, beep, boop, boop. And it's actually working perfectly. We have this one. Now, your mind immediately is starting to latch onto this and say, how many times does this loop run? This is a De Morgan's law, by the way, for those of you who like to read a really long mathematical proof later on for Boolean algebra. The cool thing here is that your mind is immediately going to say, well, this one goes around 10 times. This one goes twice for every 10 times. 10 and 2 is going to be 20. Well, let's see if you're right. So I'll go ahead and say counter equals 0. We'll start it at 0. And we're simply going to sit here and say counter plus equals 1. And then what we'll do is come down here is we'll say print, it went around counter times. All right, ready? Ready? You would be correct. That is the simple way to do that one. You're simply going to do the multiplication. Now you're sitting here going, oh, this nested loop wasn't too bad. I could definitely see where that could be pretty useful here. Beep, boop, boop is not terribly helpful there. I guess if I wanted to be a little bit more technical here, I could come and do something like this. Just to make it look a little bit more normal. Let's try this just to see if I clean it up. There we go. I don't love it very much. I guess we'd have to put a space here or something like that. And technically we could come in here and do the same thing here. Let's see if this is a little bit cleaner. Oh, there we go. Beep, boop, boop, beep, beep, boop, boop, beep, beep, beep. So I guess technically, I think I win. Yes, nice. So you can see here that my little thing is working pretty darn effectively here. The world's most complicated way to say literally this line and put it under a print 30. So this works pretty well so far. Now, inside of any of these nested loops, you're probably sitting here going, okay, so I get it. So you can loop a loop. I mean, like, does this get complicated? Yeah, it can get pretty complicated. This is one of the things I like about this. So let's say we want to create ourselves a really, really complicated loop that loops 3 things. Are we allowed to do that? For sure. So I'm going to grab x in range 10. And I'm going to say for y in range 10. And because science, I'll say for z in range 10. To go ahead and check your math here. 10 times 10 times 10. Ooh, this one's got to go on a lot. So what I would do is I'm going to print x, y, z. Now, if I were to run my code here, you will notice the fact that it gives me a bunch of digits. Anybody trying to keep track of all the combinations that you could have on a 3-digit watch or lock there can see very clearly how all that stuff gets generated in that bottom left corner, basically perfectly, which is exactly what we expected it to do. And when you're doing these, you're allowed to kind of bang through it like that, which is one of those things that makes it so darn effective when you're making these nested loops. Now, when you make nested for loops, there's a couple other things you have to be kind of cautious about, and that is going to be trying to combine different types of elements together. So what I want to do is create a list containing most cards in a deck. Ooh, let's put a hashtag in front of that so we can be polite here. Okay, this is a great use of this. Fantastic, fantastic use of this. So let's say we know that a deck of cards usually contains, what do we have, 2 through ace kind of a thing. 2 through ace. So that's going to be, the cards are going to be 2, we'll keep it 3. 9. This will be a jack. This will be a king. This will be an 8. Let's see, we need a queen in between all that, don't we? And then, of course, we need an ace. Now, we also notice there's our 4 suits. Now, there's a bunch of different ways to do this. And when we go to think this one through, we could really just take a list and basically add stuff to it and run through it 3 or 4 times. But for us, we're going to go ahead and try to keep this relatively straightforward. So I'm going to start by getting myself a list called values. And in that list, it's going to contain all the possible values that we can have inside of a deck of cards. There we go. Isn't editing cool? So now we're going to go ahead and define the suits. Suits equals hearts. Let's see if we have hearts. Everybody's going to be like, why are you making one type and not the other one? But that's okay. We'll say clubs. And of course, we're going to get ourselves spades too, because science. Now, we need to figure out a way to iterate through all of these once to attach one of these to it. Aha! See what I did there? Let's see if we can figure this one out. So we're going to say for suit in suits. So remember, there's going to be 4 suits, and there's going to be all these cards locked into that suit. I'm going to come in here now and go ahead and iterate my second one. I'll say for value. I'm going to call this one. I'll be careful. For value and values. So what we're doing is we're iterating through these 4, and then we're going to be iterating through this whole list in a nested situation. So now all we have to do is define the card. I'll say card equals, keep it nice and simple. We use an F string here, value of, let's see, this would be value of suit, I believe, and just like that. That looks pretty good to me. And then, oh, you know what we never created an empty list from my actual deck. Haha, deck equals. There we go. So what this will do now is we'll go ahead and create a card, which is just going to be a string here, that'll say value of suit. And all we have to do is go deck.append card, and that's going to add each one of my cards individually. So we're going to loop through all of the different things one at a time. We're going to loop through all of these one at a time, and then we're simply going to build the list. Now, we should probably print this list here. We'll use another for loop for it. Let's do for card in card, deck is what we called it here. Print card. Let's see if it works. Oh, look at that. And you can see very, very effectively that we were able to take all of those cards and basically use the nested loop for the purposes of assembling that gigantic list rather than going hard and having to build other components. Now, some of you, of course, are going to be looking at this right here saying, couldn't we have used a for loop to generate this and then put the loop to the thing? This is one of the few times where memory is going to be cheaper than trying to create individual values, especially iteration. Iteration can be very expensive. So as you can see, we have a lot of really, really effective uses of our nested loops. So we took a look kind of at a little more complicated versions, and we actually looked at a very, very practical version for the purposes of basically building ourselves a deck of cards. Now, if we were really goofy, we could build ourselves a list that would shuffle these cards, but that would be something for another day. Enjoy.